last class, we introduced dot notation, which is naming your instances of symbols in your movie. The reason you can name the instances is so you can reference them through ActionScript. And a really simple example, which we wrapped up class, I believe, with, was this movie clip, which has buttons acting on movie clips themselves. So this movie with buttons acting on movie clips themselves. So here's the FLA file. Here's what it looks like when it's compiled. And I can press this button to stop these two wheels, and this button to start them. We've also got count up here, which has a font issue from different versions of Flash, but let's ignore that for the moment. So if we inspect the FLA, we see we have a movie clip on the main stage here, which clearly has inside of it the body of our car and the wheels of the car. And what we introduced was over in the properties for that movie clip, that symbol, any symbol, so this one happens to be a movie clip, is the instance name, car. Instance name is different than the name in the library of that symbol. So this one is capital C car. Inside the library, the instance name is different. And the reason that is because we can have many instances of a movie clip or a symbol. So we want a way to be able to reference that specific instance. It doesn't help us for our actions to reference, at least externally, the movie clip. Generally, if there's a bunch on the stage, we know which one we want to talk about. The instance name tells Flash, gives us a common language to communicate with between me as a developer and Flash as a program. 2 clicks to go inside that movie clip. Here's our 2 wheels. So in this particular little animation example, there's 2 wheels. They have the exact same animation, so it's in our interest to only use 1 movie clip. And here it is. Simple rotation. But if we go to properties, and pardon me, the name was wheel with a capital W. Go back to the properties and select each of them. We've got wheel 1 and wheel 2. This allows us to send individual instructions to those movie clips. If I double click there, it's a regular movie clip with actually some actions on the timeline, which I would expect is upping the count number, which more on that today. So this is an ActionScript 2 movie to simplify the code, which means that there's the opportunity to add actions onto a button itself. ActionScript 3, you have to write it someplace else and use the instance name to attach it to the button. In ActionScript 2, we can write directly on the button. Organizational challenge, ease of coding. Inside this button's code, we have an on release, so when the mouse is coming up from pressing this button, do these actions. This is the dot notation referencing the instance name car, and then telling wheel 1 to stop, and individually telling wheel 2 to stop. So a quick example, just to demonstrate that's what's happening. If I comment out wheel 2 and run it, only 1 wheel stops. I didn't number left to right, apparently. This notation is a certain style of notation, which we covered last class. Someone want to remind me which style of notation this is? Of dot notation, which style? There's 2 styles within it. Yeah. Absolute and relative. And further, what kind is this? Absolute, thank you, because it starts from the root of our theoretical tree and falls up the trunk, which in this case would be our car, branch, the wheel, and we're telling the branch in our now tortured analogy to stop. That's an absolute reference. This particular notation is completely valid in ActionScript 1 and 2, except it's no longer favored excuse me, by Adobe. We also covered relative notation, which is in reference to where this code exists, where are the directions to send this message to. So in our tree example, if one branch needs to talk to another branch, it could say, go to my parent, the trunk, and from there tell the branch. It need not go all the way to the root, because their relative relationship to each other is up one, down one. Up my parent, down to another stem of it. That relationship would continue to exist if that particular branch got moved up the tree and outwards. That relationship of up one, down to the other one would still exist, where if that relationship was moved, the absolute would have changed because we're no longer a couple steps out on that particular branch. We are now a different branch, many more steps. Luckily, you don't need to master all this or remember all of your instance names when using Flash. There's a target pathfinder, which shows you all the named and unnamed instances in Flash. You can select an unnamed movie clip. It is a recipe for failure. I'm telling you, it will not give you a mark demonstrating your knowledge on anything if you don't refer to a named instance. If you let Flash suggest the name, it's A, problematic, and B, not good form. I do have referenced in here car and wheel. I can see at the preview of my top the dot notation to the path I'm selecting. Relative. So this is how it starts. Short form for, or an alias for wherever we currently are is this. It's implied in some cases. If I were to say, if I was writing code, in this case right on the main timeline, and I said car.wheel.stop, that's technically a relative reference because the this is implied. We also make it explicit when we're referencing to this, at least Flash wants to. So we use the target pathfinder. It always includes the otherwise implied this. A development in CS6 over 5 and earlier is the target pathfinder casts your reference to this as an object. We'll get all into casting, recasting, and objects when we talk about ActionScript 3, but I'm going to leave it at that is what it's doing. The syntax on the page array is valid, and so is this. So if I chose to talk to wheel 1 and tell it to stop relatively, I can choose that with my mouse and then type in stop, or just type the period myself and go to the ActionScript directory and choose stop. I can also do it the relative way. Oh, I didn't choose relative, pardon me. One more time. Oh, absolute, pardon me, that's what my problem is. Absolutes, we're going to tell wheel 2 to stop in the absolute method. So root, referencing all the way bottom to the bottom of our analogy of a tree, going all the way down to the root and follow it up. Not say in reference to myself, but say in reference to the toppest part of this hierarchy, here's where this message needs to go. I'll press the period button and add a stop. So these are exactly analogous lines, 3 and 5, 4 and 6, do the same thing, different syntax. If I were to run it as it is, there'd be no change because I'm just issuing the same command. Flash doesn't care if you do the same thing twice, maybe you might, but it's going to just do it twice with no output. Only that obscure efficiency reason why you might not want to do it. And there we are. Stop, and it starts in the old code. So that's a recap. I'm going to extend it a little further. In Sakai, in the resources folder, we've been working through these folders. We're now in Intro to ActionScript. Here's our start pages. Object paths and dot notation talks about scope and targeting. So I talked about the scope, didn't use those words, but the scope is where I'm working in, where my code lives, and the foreign scope of where I'd like to send messages to. This being the implied scope of any one moment, I can only access without prepending the instructions with an address to direct it to in my local scope. That's useful for if I had a number of cars on the page and they all had wheels named 1 and 2, then I want to be able to send it specifically to one area. If they're all in scope at that one moment, it wouldn't work, but because they're in their own respective scopes, I can send the respective message to them. Here's a breakdown of the relationships between the whole movie. So Got our main stage, known as root in our absolute terms, otherwise it's this in the local scope if you're writing the code on the main timeline. In this movie clip we've got two movie clips, car and bike. Pretty obvious without looking at source file. Here's what their names would be in our different ways of doing notation. We've got absolute, root.car for car, same root.bike for bike. Relative, if I am speaking about myself as the car, I refer to myself as this. And this relationship to the wheel is it is the parent of wheel 1 and wheel 2. Inside that movie clip we have wheel 1 and wheel 2. So the absolute reference for wheel 1 is root.car.wheel1. Its own relative reference to itself is this. Relative to the car, so if the car was trying to reference wheel 1, it would be this for me the car, dot wheel 1. And relative to wheel 2, wheel 2 would say, hey my parent, the car, tell something to wheel 1. So that's its relative references to each. Apologies on the working FOA file for you, but this is the point of those files. Jump over to the bike. Same relationships to each other, different name for the movie clip. When you're referring to yourself, you're this. You can always refer absolute by going from the main stage and up, and that's the basics of the scope in Flash. Okay, so back on the record. Survey says if no one had any further questions, but if I asked them to do it, they couldn't do it, was the general consensus. So let's build a simple example. So if you guys come up with Flash, I'm going to move at a pace. So if you can't keep up, probably want to watch my screen. If you can keep up, then you'll have your own working artifact. If something in between the two is your best option, there you are. But I am going to move at a pace. I'll start with something to animate. So let's convert that to a movie clip. And inside here, let's keep it really simple. It's a shape tween. And let's delete it. Oh, that'll work. Nice predictable shape tween. So rarely happens. So I've got that as my really simple movie clip. Inside of there, we just call that symbol 1. I'm going to add another layer and make another simple drawing. And we'll convert that into a symbol. Very importantly, a movie clip. And let's do a 10 frame classic tween, and they'll let it warn me that or it won't warn me actually with the classic tween. And then I use the classic tween because now I can tell it to rotate. So that's our basics there. We've got one movie clip on the main timeline. In that movie clip is a shape tween with the shape collapsing on itself. Also in that movie clip is another movie clip that contains an animation of a spinning something or other. So that's our basics. To make this that much more complicated, I'm going to add a motion tween in the main timeline. And just move this movie clip. Oops, pardon me. Gotta make sure I'm inside the actual motion tween there. And let's get rid of this extra keyframe. We don't need that. So the reason I did that is we can see on the main timeline we have some motion we can track. Inside that movie clip we have some motion we can track, and inside that again we have some motion we can track. So hopefully that relationship gives us something to tease out what's happening with our actions. So I'm going to call this our simple framework. And step 1, Feb 14. Save that file, and if you want to follow along on Sakai, create folders, Feb 14, 2013. And stand right in the face. I'm going to move that into our intro action script. So in intro action script, Feb 14, upload a file. Step 1, Feb 14. Okay, so it's up there if someone wants to grab it. Got all these motions isolated. Let's give them some instance names so we can work inside Flash, as this is our demonstration or our test harness. So my first movie clip, can someone give me an instance name? Take anything that doesn't start with a number. Line is our first one? Yeah. Line. Make sure I've got my keyboard on the right box there. Line. Lowercase. 2 clicks. We got this other movie clip. I need a name or an instance name for that. Curve. Okay, and then that should be, for this example, all the instance names I need, because this last one, there's nothing in there. We may come back and use it to exploit something else, but to start with, 2 instance names will do. Okay. Let's make some buttons. And we use those buttons to demonstrate some of our action options. And we'll build a local scope into directing from our local scope to another scope. So I'm not going to make any buttons. I'm going to go into the common library, grab a button, which I think was already on there, wasn't it? Yes, it was. Common libraries, buttons. Button bar. Okay. So we've got a button. It's now part of my library, plus the other things I was messing with. We won't have an exemplary library here, just being pragmatic. What I'm going to do, speaking of being pragmatic, I'm going to leave all my buttons as one label. So 2 clicks here. Just changing enter to click, just to make that point. And I'll throw some text notes beside them to demonstrate what we want them to do, because that seems like a really simple way to build our buttons. So classic text tag, text perfect. Stop main movie. What this button is going to do for us in white. Stop main movie. Again, you don't have to have something exactly like this. I'm close to saving this as step 2 and throwing it up in IASC Sakai. So let's express that in some actions. I'm going to right click this mouse button, ask to see its actions. We're using the ActionScript2 method for associating something with the button, because it's the least lines of code. On, release, do something in here. So it's going to stop the main timeline. What would be the named function, which is how we refer to these functions on the left, to stop the main timeline? Someone want to give me that? Nowhere near as complicated as my question made it sound. Stop! Thank you. Stop. That should do it, and indeed. So our main timeline had that motion tween. You can still see it on screen. To move it across the page, hit stop, main timeline stops. the timelines inside our movie clip continue on. They received no instructions. The scope was the main timeline. So far, so good. We start that, and boom. So I'm going to call that step 2 now, and I'll upload that. It's not the 7th. Sorry for the inconsistent naming convention. I'll fix it later. Okay, so we've got a really simple one. For the sake of having a movie we can keep working with, I'm just going to quickly copy that. Play, main movie. Let's use the terminology timeline. I think that's easier for everyone. Okay. And I'm going to, because I copy and pasted it on the stage, the old code's still there. We'll add play, type it properly, it will work perfectly. Easier said than done. Okay, stop, and then start again by issuing a play command. So we've got a basic way to use our local scope on the main timeline. Let's get more complicated than that. Go cut and paste these again. And line, I believe, is our instance name. So I'm going to make those notes now. No effect on the code yet. This is just redundant. It's just what I copied over. So to affect the line instance name, let's go to our target path finder. Let's go on default to relative. That's our most robust because if we change the structure a lot, that will keep working. So I'll use that example. Let me know if an absolute would be a better example for you. We're going to tell line to stop. And then on this code, or this button probably, we're going to associate the code of tell line to play. Here we go. So you can see line, that movie clip where the box compresses. And there it is frozen at that point. It's not restarting, but I sent the stop message just to line, so everything else continues on. I could also stop the main timeline, so it stopped in place. I could then play curve. You can see how this different scope affects different spots. And then I'm going to do another save after this. Next logical step. I didn't like that hint. Give me a hint on this other side. There are ways I can fix that, and I'm only going to take one of them. A little better. Okay, stop, curve. So again, cut and paste the last actions. Let's get rid of them all together. Target path finder, line, curve. There we are. Dot, stop. Think unintentionally, this has demonstrated how disinterested our ActionScript interpreter is to the position in the white space of our code. It only cares where those semicolons end up, ultimately. But for human readability, sometimes it's nice to tab them in or not. In my arts-based Flash instruction, I'm not too concerned. So let's stop curve. There we are. Play it again. Stop the main timeline, stop curve, just that one. Okay, so if I didn't give you this file, by a show of head nods, could you reproduce it? Most head nods are going up and down. We've got a lot of abstentions, but no no's. I'm taking that as a signal and move on. Okay. Let's save another FLA file. And I'll upload that. Okay, let's add complexity, stuff we haven't covered yet. But still doing it with the cut and paste. I'm going to go down all the way to what was the curve instance. I'm going to add a new layer, and on that layer, paste in my buttons. Now position them about here. So those buttons are still labeled stop the main timeline. That is our goal. I am not going to change the code. Let's see what happens. So to make this easier, I am going to stop line. Oh. Do I have a compile error along the way? One thing we have definitely covered is it only takes one syntax error to throw everything off. What changed? Oh, there we are. What changed? My dexterity. So let's play that again. Better. We can keep this one playing, because that's fine. So the goal is to stop and start the main timeline. I've already stopped it. Let's try and get the play. No luck, but stop would stop that movie clip because the implied local scope. Looking for head nods again. Makes sense? Little worried face. Mostly nods, yes. So I'll go back and so the reason it only stopped the curve movie clip is because the code is just play and stop. And it's located inside that movie clip. So without telling it where to direct those instructions through our dot notation, it implies it's the local scope. And so it's just like saying this dot stop or otherwise undirected, it's stopping just inside that movie clip. Okay? Just like when on the timeline we put a stop at the end of a movie clip to make it stop. Just like that. In fact, in Action 3 you could only put that instruction on the timeline. So let's fix it. We want to stop the main timeline. As we've been over a couple times, there's two syntaxes to do it. I think it's useful to do both. So let's do both. Start with the default relative. I want to tell the main timeline to stop. I hope this works. Didn't work. Target Pathfinder lets me down on the relative. So I'm going to do it myself. Parent.parent would be the most relative way to do it. Or is it single? I think it's right here. So I am the curve. Oh, I was right the first time. Anyone else checking my work think I'm right? No opinion. I think that's fine. I'll take that. Let's find out. So let's stop curve, or line, pardon me. What's happened again? Am I just running again? Oh yes, thank you. Good thing someone's paying attention. Next time I make that mistake, I'll try to make it look deliberate. So our problem is, I only changed to stop, and I'm not going to be able to click that. So let's use play. Okay, so here's our attempt to manipulate a play on the main timeline. And we are going to have to get the help of the existing buttons to stop curve. Stop main timeline. There we are. So we can play this, I guess. We're going to try and restart the main timeline. Here's hoping. Hey, it worked. So that was going up 2 in our relative reference. So parent, which is line, its parent, which is the main timeline, the root. This is the same location we're referencing through our dot notation as the absolute reference of simply root. Tell the main timeline, the root of all this complexity, to go and play or to stop. There we are. So it will play again for me. So that's our 2 relative and absolute syntax. Clearly in this case, it was really helpful to use the absolute because the target pathfinder understood what we meant. It's unfortunate it still didn't understand what we meant. I was able to hand code it together by knowing 2 parents up. That was tricky, obviously. But that trickier relative would be more robust if I went back to the main timeline, selected everything, converted that into a symbol. Now we've changed our absolute references. I have to give that new thing I converted into a symbol, an instance name, and I have to update any absolute reference to it to include that new instance name. If I did that same scenario, the relative would keep working. The relative just knows, go up 2 levels, tell that thing to stop or play. Okay? So we're looking at hit test on clip event. Hit test is a concept that's in Rosenweig chapter 2. In Rosenweig, he discusses hit test point, hit test object, which are the splitting of these 2 tasks in our ActionScript 3. We're going to move towards that, but the progress through 2 is to do it the simple way and build complexity. But it is in there. The concept is exactly the same, a little different syntax and a little more complexity because there's 2 types of hit tests, usefully, and also the ways that you inquire, are these 2 things hitting each other? In ActionScript 3 is more complex. These listener concepts are described in there. We aren't covering listeners quite yet. We'll pick that up after the break, but that's how it's done in ActionScript 3. ActionScript 2, we are going to use on clip events. So here's a description of hit test linked in Isaac Sakai. But I'm going to come back to that after on clip event. On clip event, so we've had a chance to look at on clip enter frame. We looked at the 2 on clip event, the 2 events we're concerned about for almost the majority of the work we do is this being loaded? Only happens once for the most part. At the start of the movie or when the keyframe brings us onto the stage, it's a load. And enter frame, fired every time a frame goes by. The latter being really important for hit testing. So I mentioned there's 2 different syntaxes between ActionScript 3 and ActionScript 2 for hit test, but simplest version is ActionScript 2. So what we're going to do is apply that now based on this example in Sakai. So we've got 2 movie clips on the stage. It could be graphics as well. On the main timeline, we have 2 tweens, motion or classic. Don't remember off the top of my head. And they must be movie clips. The motion's in the movie clip. The way I know that is as you watch this, you can see sometimes they hit, sometimes they miss. That's because the individual movie clips have different amounts of total frames. So I can't perceive this. If someone can, let me know, and we'll check it on the actual FLA file. One of these 2 tweens has less frames and it's happening faster than the other, which is why sometimes they hit, sometimes they miss. Circle, you think is faster? All right. We'll check that out. So that's our animation. Screenshot at the bottom of this is the only actions in this whole movie except for, I think, a stop. And this is the actions associated with, actually, you can tell from here. I'm curious if anyone can figure it out. Which of these two movie clips would these actions be associated with? You got a 50-50 chance, if you want to guess. You're going with circle, Matt? Sure. Circle is the correct answer. Circle gets the square. The circle is it because you can see right here there's a reference to this, asking about a foreign scope underscore parental block. So block is the instance name of this red shape here. Circle is the instance name of the blue circle. Code is associated with the circle. So we've got our on-clip event to ask what's inside these brace brackets every time a frame ticks by. So there's no motion that it will escape its view because every time a frame ticks by, it's asking. What it's asking is an if statement. We've covered if and else before very briefly because there seems to be a very high level of prior knowledge in this room about if and else. It's not the case. Correct me at some point. We're asking if this, otherwise implied, but hey, let's be clear. This being the circle in this case, dot hit test. So we're asking this hit test property of circle. Hit test property is like go to and stop, go to and play. We need to pass a parameter. It's not like stop or play where you call it, we know what the output is, and there's no need for an input because it's such a simple output. Hit test needs a parameter. It needs a what are we testing against? What am I possibly hitting? So you're saying myself, what am I hitting? Or am I hitting this thing? So we're using the absolute or relative notation to reference the block. So I want to disambiguate that. Is it absolute or relative? Focus on this part of the room here. Sure. Relative, yes. There's absolute, you'd see root in there somewhere because it's referencing parent. So from wherever I am, go up to the parent and look for block. It's relative. Even the word parent implies relative. So we're going to cover functions that you create. So inside Flash, we have this concept of functions that come with Flash and named functions. I've got some links off to Adobe helping, Adobe's documentation on writing named functions. So functions that you declare, not ones that came in Flash, you're building. And a couple other examples. This is a simple file that lets me work with this text here. So let's recreate this. First thing we need to do is address the issue of text in ActionScript, or in Flash probably in ActionScript. So let's make a new movie clip. And we need to, let's reset my workspace here. There we go. So I'm going to add text to my my stage here. One thing we glossed over 5 weeks ago was there are 3 types of text. Static text is text that you type in to label things, and when you compile that movie, it looks exactly how you created it, even if you use a fancy font, because there's no modification to that from your code or from your user. Dynamic text is text that your ActionScript can modify. So ActionScript 2 has this quaint little way of sharing a variable with the rest of your actions. It's really more of ActionScript 1 than our theoretical 1 version. We say, oh, I created a variable somewhere. Make sure whatever is in that variable is always displayed in this text box. This is one of our key moments of ActionScript inefficiency and why this is such a CPU wasting technology under ActionScript 2. And we're going to avoid that. There's also a property for a named text box, an instance named text box, to set its text. And that carries forward in ActionScript 3. So we're going to look at that now. So dynamic would let us, through ActionScript, update that text. Input text allows the user to update that text. They can type in their name. They can add information into that box. It's something that's selectable. Both dynamic and input text are dependent on the fonts that arrive, that are available to that Flash movie on the user's computer. So if you use your crazy fancy font, it will, here we are, it will not be on the user's computer unless you choose to embed it. Embedding is a semi-complex process, like we've got our dialogues here. There isn't too much to it, but it is a really big chance to up the file size of your Flash movie and noticeably harm its displaying on the page, even in a high bandwidth situation, because the font size is comparatively quite large. Font file size is comparatively quite large to your Flash movie. Because of this, there are a dialog that I've opened up here. It allows you to choose what we need to include. Maybe not all glyphs, characters in the font set. Looks like, I think, if I'm interpreting it right, 9,000. No, must be the first 737. And I don't know how could there be that many glyphs unless it's for different variations adjacent to different letters. Or just the numbers, just the punctuation lets you shrink down. Oh, there's also a different language set in the veranda. That's what the problem is. So I bet all is all English. Oh, and then we also have to worry about italics, regular, superscript, etc. So font can be quite large. It's generally in your interest to use the ones that come with any web browser. So a sans serif, no serif, or serif, the feet and ears on top of fonts. You can not have them, or have typewriter or monospaced font, so keys that look like type keys on a typewriter, or an old terminal shell, DOS command, Unix prompt, where all the characters are the same width. So if you use those, you can be, for your input fonts, for your dynamic fonts, you can be sure they're on the viewer's other end. Fonts like Arial, I don't think anyone in this room has used a computer with an Arial on it. You're making a fair assumption. Comic Sans, unfortunately, it's everywhere. But sticks, integrals, up D, is that, am I right reading that correctly? I don't have the knowledge to tell if these kanji characters are going to be on various systems or not. So these are the decisions you need to consider if you use the non-standard fonts or the default fonts. So let's use some dynamic text. Options down here are to have a border around the text. Probably not something you really want with static text, but often something you want with input text, and let's say about 50-50 with dynamic text. In our case, we want it on. Otherwise, we're looking for a white box in the white background. You can also choose to render the text box as HTML. That gives you some styling options. I think almost everyone in this room in our earlier survey at the start of the class has come in contact with writing a little bit of HTML. So there's font declarations there for italics, bold, in a couple different ways. You can set those in there. Downside of using the HTML, renders HTML, if it's the input box, you can get some really interesting HTML marked up input from your user just from them typing in their name. If those know HTML, their space may be between their first and last name turned into an ampersand MBSP semicolon, which means space in the HTML entities character set, but your code probably won't like that. So, a little warning with that. Also, some aliasing options and font options. I think we're generally familiar with that. So, empty text box, put a bounding box on it. There it is. I'm currently choosing Veranda. I'm assuming that's on the user's computer, or I could go back up with a sans serif. It'll look pretty similar. So let's throw something in there. We need an instance name. Text1 works for me. And I'm going to insert some actions on the timeline. I'm going to use my target path finder, text1. The property is text that we're going to set, and equal sign to assign the value. We assign from the right to the left. Our hello world, the semicolon at the end. There we are. Already demonstrations of consideration one must have with dynamic text. So let's make sure this is large enough. Now it fits, and let's go over into our paragraph options, center it, looking more useful. Okay? So I'm going to leave text1 on there. I'm going to start building text2. Hopefully that's simple for everyone. I'm going to give text their own layer and our actions. What I'm going to do is build a more than one frame movie. No extra keyframes yet. And I'm going to put in another text box. And we'll call this text2. And we're going to do a little bit of sloppy coding to make a point. Best part about recording it is that I can now track how much time I waste rearranging Flash panels. Library. Snap right here. Okay, now actions, you come with me. I think we got something that's workable. Okay. So here's timeline, you can see there. Here's my properties. I don't know how I deleted that, but we're still, I think, in positive territory here. Dynamic text, that's what we wanted. Text2, hey, it's catching back up with us. Maybe I actually had it selected. I'm going to make sure it's got that box around it. There we are. Looks good. Okay. So let's actually do the actions that we wanted to affect in the first place. Here's where I come into danger moving this box. Let's reference text2 dot text. So that's going to get us the contents of that folder. What are we going to do with it? Let's put it in a temporary variable. And then let's write in some long form code, adding one to it, and then let's put that variable back into text. It's a little sloppy. We are, for our persistence, keeping this in the text box and allowing Flash to redeclare a variable every time it loops, but hopefully this is going to work. Oh, and then there's our problem. So, because we're allowing Flash to store the result in between as inside the text box, it's considering 1 to be text. So when it's adding, it's making 111, putting 1 beside each other. So there's a couple ways we can fix this. Our sloppy method we can maybe rescue, but let's work around it too. Let's just do times 1. Oh, and now it's saying that's not a number. All right, we're warming up here. So let's do it right. What I'm going to do is I'm going to leave declaring number on this page and finish off the actions right there. What I'm then going to do is insert another keyframe in my actions layer. And first thing I'm going to do is num++, which I think we all are familiar with, is add 1 to this variable. Okay, so we don't have to do our equals, +1. ++ is our short syntax for num equals num +1. We want to stop doing that soon. And then what we're going to do is assign that into the text of text2. So now we've got our variable. We declared it here. Let's assign it. Declare it with a value of 0. So it's a number. We don't have those math problems again. We're going to add 1 to it and put that in there. So that's going to give us a 1 infinitely, because right now our movie's going back to frame 1, hitting that declare this variable, declaring the variable, assigning it to 0, very next frame, adding 1 to it, counting on 4 more frames, and just doing it all over again. So our next step, insert a keyframe, and go to and play 2. So we previously looked at our event handlers for the movie clip. We had load and enter frame, giving us a nice distinction between do this when you first show up, and every time a frame ticks by, do these other things contained in these brace brackets. We could use a similar model right here to do this. We could do all of our code over in an empty movie clip, as I referenced to earlier, and have those benefits. Another way to approach it, we're only going to play through frame 1 when this movie first launches. Then by the time we get all the way to frame 5, we're going to go back to frame 2, thus putting us in this loop between these keyframes in perpetuity until the movie replays. So it's just counting back and forth, frame 2, 3, 4, 5, frame 2, 3, 4, 5, frame 2, and every time it gets back to 2, it's adding 1. So we're finally getting some interactive stuff, at least seemingly dynamic stuff. Similarly, I could do an input box. I'm not on the right layer, so let's undo that. Inputs, and text3, or what we're calling these things? Yes, text3, named, all set, ready to go. What I'm going to do is every time we tick through frame 2, I'm just going to do a quick alert. First alert, that's JavaScript. Trace out the contents of text3 dot text. So you can see ticking by there. Because every time it goes through frame 2, it's tracing out the contents of .text. You can see as I hit the keyboard, we're getting a change. So could be prompt, what's your name? Press this button, and then the button now knows, say, hey, I can see this is your name. Okay, so finally got a way to modify something more than just frames from our movie.